In this video, we'll talk about solving inequalities involving multiplication and division. So let's jump right in with an example. Let's say I wanted to solve this inequality, 3x is less than 12. And I think what we can kind of recognize here is that, okay, well, 3 times 4 makes 12. So therefore, x should probably be less than 4. If I pick 4, I'll be at 12, and that would be too much. If I pick 5, that's also too much. If I do 4.5, that's too much. If I pick 3, though, we're good. So if we kind of think about what would happen if we were trying to solve 3x is equal to 12, our first step would be divide both sides by 3. That means x would also be 4. In this situation, if we divide by 3, it would kind of make sense that, okay, if I'm essentially taking a third of both of these, that this inequality would still be maintained. It would be fine. And what would happen is that x is going to be less than 4, which again makes sense given our thinking. So we would plot this on a number line if we were asked to do so. We would start at 0, we'd go to 4, we'd put a hollow dot, and we're going less than, so it would be to the left. And this would be how we would plot our solution. Now what we're going to do is we're going to look at another example where things may not line up with our thinking. So let's look at another example. If we're looking at negative 2x is greater than or equal to 10, well, if we're thinking about this, negative 2 times negative 5 is equal to 10. Positive 10, I should specify. If we try negative 4, we'll get positive 8. 8 is not greater than or equal to 10. If I try 6, I will get 12, or negative 6, I'll get a positive 12, which would mean that negative 6 works, and negative 5 also does work because of the equal to case. So what we're doing is, or what I'm thinking, is that if we're looking at x, it has to be technically less than or equal to negative 5. And the idea is that we are increasing our distance from 0 there. Now that's kind of it's intuitive. We kind of have to think about it a little bit. And if we were to solve this as an equation, if negative 2x was, say, equal to 10, we would divide by negative 2, and then x would be negative 5. And that would make sense to us. We flip the sign there. However, if we apply that thought here, what's going to happen is that x is going to be greater than or equal to negative 5, which would mean negative 4 would be a possibility, but we already know that doesn't work when we plug it in. So we have to be very careful applying our algebra skills when we're dealing with a negative, if we're dealing with multiplication or in turn division. So there's two approaches here to how we can solve this. The first is, okay, instead of dealing with a negative, we've already shown that we can deal with positives, no problem. So what we would end up doing is we would essentially add 2x to both sides. So if I had negative 2x is greater than or equal to 10, I don't want to deal with a negative on my x. I'm going to move it over so that it's positive. So then what's going to happen is that we will be left with 0 on the left side of the equation, and that'd be greater than or equal to 10 plus 2x. Now my x is positive. Excellent, we can deal with that. The other option now is we subtract 10. We can add or subtract. We talked about that in the last lesson. So negative 10 is going to be greater than or equal to 2x, which now we know we can divide by a positive, no problem. Therefore, x is going to be, or I guess I should write it the same way we have it here, just for emphasis. Negative 5 is going to be greater than or equal to x, which makes sense with our thinking up here. The other option is to solve as you normally would. However, just keep in mind that if you divide by a negative, you have to flip the sign. So if we have negative 2x is greater than or equal to 10, we're going to divide by negative 2. And then for myself, when I do these, I normally put a little asterisk or a star for myself. So that way I know I have to really flip this inequality. And if I do that, x is going to be less than or equal to negative 5, which, again, lines up with our thinking. And if we were asked to plot this solution on a number line, we go to 0, go over to negative 5, we'll make a solid dot, and then we will go to the left because we are less than or equal to -5. So when you're dealing with inequalities, if you are multiplying or dividing by a negative, you have to flip the sign, or you have to use addition and subtraction to create a positive. The choice is really up to you. You can do it however you like. If you're not a fan of having to remember that the inequality flips, then I would suggest going with what I've outlined here in red. Now, the reason that it doesn't so much affect an equation is that, well, equal is equal. It doesn't really matter which way I write it. However, there is a huge difference if I write x is less than 5 or x is greater than 5. The direction matters there, and that's why balancing on sides is kind of tedious in inequalities. So you just have to be very careful with negatives. Anytime you see a negative, ask yourself, okay, can I do this? If you're adding or subtracting, it's fine. If you're multiplying or dividing, you have to be very careful. You really have to ask yourself, okay, do I need to flip my inequality sign around here? Now what I'll do here in this example is just real quick show the same laws or the same idea applies to division. And the reason for this is that I can write this instead of x divided by 4, I can technically write this as multiplication, 1/4 times x. I'm not going to solve this problem out just to keep this video somewhat brief, but the idea is that the same idea applies to division, and also with the negative, the same thought applies. If this was a -4 down here, my first thought would probably be to multiply by a -4, and then what I'd have to do is I would have to flip this inequality. For the same reason with the multiplication. If I'm adding, or if I am multiplying or dividing by a negative, I have to flip that inequality. So just keep that in mind. That's kind of the main takeaway. This is really the only difference in solving inequalities versus solving equations. So, in general, if, let's call it a times x is, let's use less than as an example, less than b, then two possibilities exist. If a is positive, meaning it's greater than 0, then x is less than whatever b divided by a is. If a is negative, meaning it's less than 0, then x is greater than b over a. And notice that here I used a less than. However, if this was greater than, then both of these signs would flip as well. So the same idea applies. Basically, yes, I can do the same thing with division. I can do the same thing with multiplication as I would solving equations versus inequalities. However, this being the one caveat here. If I'm multiplying or dividing by a negative, I must flip the inequality. And again, that's the main takeaway here. That's really the only difference.